Welcome back, guys. We have reached the last lesson of Chapter 3, Lesson 3.5, Solving Systems of Equations. So the first type of system that we're going to look at is when we have linear systems. And linear systems, in our case, are going to have two lines. Two different lines that somehow are related to each other and form a system. So let's take a look at example 1. Here we have y equals negative 2x plus 4. And we have the other line, y equals 3x minus 1. The first way we're going to solve these linear systems, the first way we're going to do it is through graphing. So what you do in graphing is we're going to graph both of these lines on the same xy plane and see where the two lines intersect. Wherever they intersect, that's going to be our solution, okay, to the system. So let's do this line in this color. So we can look at this. This is in slope-intercept form. My intercept is at 0, 1, 2, 3, 4, right there. That's my intercept, my y-intercept. And my slope is negative 2. So I'm going to go down 2, that will be negative, and over 1. Notice that a negative slope, your line is going to be angled in this way. A positive slope will be that way. All right? So this is a negative slope. So this makes sense that it is doing something like that. Again, that is y equals negative 2x plus 4. And then for this line, let's do it in this color. My y-intercept is at negative 1, so at 0, negative 1, and my slope is 3. So I'm going to go up 3, 1, 2, 3, over 1. Okay? And once you have 2 points, you just connect your dots and you got yourself a line. So easy peasy. Now the solution of this system is where the two lines intersect. So that point right there, which is at 1, 2. So my solution is at 1, 2. And that's how we find a solution of systems graphically. Well, what if we didn't want to do a graph? What if we wanted to find it algebraically? That's the second way. Okay, in this particular case, we have y equals negative 2x plus 4, and y also equals 3x minus 1. Now, if you remember, maybe in geometry, yeah, if we had something like a equals b and a equals c, then we could say if both b and c are equal to a, we can say that b and c must be equal. And that makes sense. So if a is equal to b and a also equals c, then we can deduce that b and c must in fact be the same because they're equal to the same thing. Well, same thing here. This is equal to y and this is equal to y. So that means together they must be equal to each other. So that means negative 2x plus 4 must be equal to 3x minus 1. Because again, they are both equal to y and y equals itself. All right, so once we have this set up, now we're just going to solve for x. So really, really easy. I'm going to go ahead and add 2x to both sides. It doesn't really matter how you do this as long as you do it moving your x values to one side and your constants to the other. And then I'm going to add hold on. Yeah, so add 2x to both sides. That's going to go to 0. This is positive 4, sorry. That was what I got confused there. I don't know why I put a negative. That goes to 0. So you're left with 4 equals 5x minus 1. Then we're going to add 1 to both sides. And that's going to give me 5 equals 5x. Divide both sides by 5. And we know that x equals 1. Now remember, we need to find the solution. And the answer is 1, 2. So we do have the x coordinate, but we need to find the y. Let me see if I can focus this a little bit. In order to find the y, you need to plug in a value of 1 for x, and you can pick whichever one makes you happy. I'm going to go ahead and pick this one down here. Y equals 3x minus 1, and wherever there's an x, I'm going to put a y. So y equals 3, wherever there's an x, I'm going to put a 1. Wow, it is late. I'm so sorry, guys. Wherever there's an x, I'm going to put a value of 1. So 3 times 1 minus 1. Again, order of operations, 3 times 1, that's 3, and 3 minus 1 is 2. So my y value is 2, and my x value is 1. Again, the exact same solution. We just find it in 2 different ways. Again, the x value is 1, and the y value is 2. So the point 1, 2, algebraically, is the place where these 2 lines intersect. And similarly, the point 1, 2 is the point graphically where the 2 lines visually intersect. All right, so these are 2 linear systems. These are 2 linear systems. Now we don't have to have just lines. Sometimes we can have nonlinear systems. And oops, that's going to be the next problem. So here we're going to have solution of non-linear systems. Let's see what that looks like. So for example, one of the equations is x squared plus 2x minus 4, and the other equation, or the other function, is 2x plus 5, and together they form this nonlinear system. Now, nonlinear system just means one of them is not a line. So one can be a line, but as long as one of them isn't, then the whole system is considered nonlinear. This is nonlinear. This is obviously, by now, hopefully, you realize it's a quadratic, right? Because it is squared. This one is linear. That is a line. But together, they form a non-linear system, even though technically one of them is a line. Okay? But because both of them are not lines, we call it a nonlinear system. So how do we, what possible solutions can we have here? Well, I mentioned just a minute ago that this is a quadratic. And we know what a quadratic looks like. You get a parabola as it's the shape of its function. And this is a line. So there's really 3 possible solutions here. You can have something like this, where your line is down here and your parabola is over there, and they never cross. So there is no real solution Or you could have maybe a line here and the parabola here, and it touches only at that point. So there you would have one real solution. Or let's say we have our line here and our parabola like this, and these two places are two real solutions. All right. So this is when you have one quadratic and one linear. How about if we had possible solutions for two quadratics? Again, these are nonlinear. All right, so if I have two quadratics, I could have one up there and one down here, and they never ever cross. So that would be no real solution. Or I could have a quadratic here, a parabola here, and then just that point and another parabola there. And that would give me one real solution. Or we could have one parabola doing that, one quadratic function that does that, and another one that does that, and we would have a solution there and a solution there. So that would be two real solutions. Okay, so just looking at the different scenarios of what could happen depending on what type of equations we're using. If we have a linear and a quadratic, you could have no real solution if they never touch, one real solution if they just touch at one point, or two real solutions where you have an intersection at 2 points. If you have two quadratic equation systems, again, no real solution when they never touch, one real solution when they touch at that 1 point, and two real solutions if they intersect at those 2 points. Okay, so let's solve some nonlinear systems by graphing. Just like we did with the linear ones, now we're going to do it with the nonlinear. So example 2. Let's put solve nonlinear system by graphing. And you guessed it, there will be algebraic also. We'll do it algebraically also. But let's do it by graphing first. So here we have y equals x squared minus 2x minus 1, and y equals negative 2x minus 1. Again, I'm going to use different colors. This is going to be for the quadratic. This one will be for the linear. And we graph them both on the same xy coordinate plane. So let's do the line because that's really easy to do. This is in y-intercept. This is in slope-intercept form. So our y-intercept is at -1, and our slope is -2. So I'm going to go up 1, 2, but to the left. Okay, remember negative slope is going to do that. So let's go ahead and connect these dots. And now let's do this one. This one has a y-intercept when x is 0 at -1. So, oh my, look at that, the exact same point. It's going to be going through there. We can go ahead and just pick a few more points. So we have the point 0, -1. Let's pick 1, 2, and -1, -2. Why not? So if I plug in a 1, I'm going to get 1 minus 2 minus 1. 1 minus 2, that's -1. -1 minus 1 is -2. So at 1, we're at -1, -2. Okay. Let's pick at 2 and see what happens. 2 squared, that's 4. Minus 2 times 2, that's 4. Minus 1, that's going to be 0 minus 1, which is -1. So at 2, we're back up to -1. What that tells me is that this is your vertex, and this guy is basically doing this, but all you really need to focus on is that point. That's the point where the line and the function are intersecting, and that's the point at 0, -1. That is your solution. Not the best graph of this quadratic, but hopefully you saw that this point, at this point you had the quadratic at 0, -1, and the linear has the y-intercept at 0, -1. So that's your solution. Let's take a look at example 3. Now we're going to try and solve this not by graphing, but algebraically. I'll just let you see that for a second. Oops, sorry. Let you see that for a second. So we're not going to try and solve it algebraically. I'm sorry, graphically. We're going to try and solve it algebraically. And in this case, we're going to use substitution. So let's do example 3. And this is solving a non-linear system by substitution. Okay? So here we go. In this case, we have x squared plus x minus y equals -1. Wow, that's messy. And we also have x plus y equals 4. So this is definitely a line, and this is a quadratic. So what you're going to want to do here, since we're going to use substitution, you're going to solve either one of these for either x or y, and then you're going to plug that value into the other one. Okay? So let's step back for a minute. This one here is really easy to put in terms of y equals or x equals. So I'm going to solve this for y. This is going to be y equals -x plus 4. Okay? That's all I did. Now using substitution, this is from the second one, you're going to take this and we're going to go up here, and wherever there is a y, you are going to put -x plus 4. In fact, let's make this like a different color. All right, so we have x squared plus x minus, now the y I'm going to put in parentheses, and that is -x plus 4 equals, and then just finishing that off. So all I did is I substituted -x plus 4 for y in the first one. But the way I got this was to solve equation number 2 for y equals. All right, and now we just simplify and solve. So here we go. This is x squared plus x, and we got to distribute that negative. So this is going to become plus x minus 4 equals negative 1. And this is just x squared plus 2x minus 4 equals negative 1. Again, we're going to get to the point where we want to factor this, so I'm going to add 1 to both sides so I can get a 0 on the right side. And that's going to give me x squared plus 2x minus 3 equals 0. And we know how to factor this. This is an easy one to get our answers. X and x, 3 and 1. Excuse me. This middle term is positive. That means that the larger number, which is the 3, will be positive, and this one will be negative. So this means that our solutions are x equals 1 and x equals negative 3. Okay? So I'm going to have two solutions here. This is a quadratic and a line, and it's going to have two solutions because I have two x's. So we know this is going to be one of those, right, where it crosses at two places. So for our first point, we have the point 1 comma something, and for the other one, it's negative 3 comma something. I recommend that you plug these into this one because it's really easy to figure out. And so we're looking for y. Y equals negative x. We're using 1 first. So that's negative 1 plus 4. And that's going to give me 3. So that's my first solution. And for the other one, I'm going to plug in 4x. I'm going to plug in negative 3. So y equals negative 3 plus 4. Now remember, the negative of a negative 3 becomes positive 3. And 3 plus 4 is 7. So this is 7. So my solutions then, let's put them over here. Are the point 1, 3 and the point negative 3 comma 7. Okay, hopefully this is making sense. All right, let's move on to example 4. Now here, I'm going to have two nonlinear functions. These happen to be two quadratics. I'm going to have 2x squared minus 5x minus y equals negative 2. That's one of them. And then the other one is x squared plus 2x plus y equals 0. Here we're not going to use substitution. We're actually going to use a process called elimination first, and then we will eventually use substitution. But here we're going to eliminate a term that we can easily get rid of. In this case, if we added these two. So if you look closely, you can see that there's a negative y and there is a positive y. And a negative y plus a positive y is going to give you 0. So we're going to get rid of the y's. So I'm going to add these two quadratic functions. You add like terms to like terms. So 2x squared plus x squared, that's 3x squared. Then you have negative 5x plus 2x, that's negative 3x. These guys go to 0, which is exactly what you want. You want to get rid of the y, so that you can solve for x and then eventually get your x value, plug it back in, and get your y. And over here we have negative 2. Now we're going to move everything to the left so we can factor this. And this is going to become 3x squared minus 3x plus 2 equals 0. At this point, Excuse me, this cold is just not going anywhere. In order to solve this, hold on, let me get some water. I recommend that you just use the quadratic formula. This one is always going to work for you. You already know it. And if it becomes a situation where it's an imaginary solution, it's going to be perfect. You'll be able to get it. So it's already ready to go for quadratic formula. Your A is 3, your B is -3, and your C is 2. And the quadratic formula, hopefully you've memorized it. -b plus or minus square root b squared minus 4ac all over 2a. So that's x equals, now our b is -3, so that's -3. And again, I'm going to go back and take care of that in a minute. Plus or minus square root of -3 squared minus 4 times 3 times 2 all over 2 times 3. Okay? Let's simplify this. The negative of a -3 is just a +3. And now we're going to take care of what's under the radical. So we have, remember, order of operations. You want to do parentheses, exponents, multiplication, division, addition, subtraction. So we're going to do this exponents, -3 squared, that is just 9. And then over here we have -4 times 3, that's -12. -12 times 2, that's -24. And down here in the denominator we just have 6. Okay? This is going to give me square root of -15 over 6. Well, thank goodness we did quadratic formula, because we're going to get an imaginary here. And this is going to be 3 plus or minus I. We just pull the I out. Square root of 15, nothing you can do with 15, over 6. So this means it's imaginary numbers are our solutions, so there are no real solutions, which means that these two guys over here, up here, these two guys are going to graph something like this, maybe one over here and maybe another one over there, and they shall never meet. Okay? So that's a no real solution. That's what it would look like. But it does have imaginary solutions. It has 2 of them. Alright guys, and that, my friends, is the end of 3.5. Like I said, this is the last lesson for this chapter, so be on the lookout for a study guide for chapter 3, and then you'll be ready for your chapter 3 test. Alright, see you next time.